For our next topic, we're going to look at what are called binary relations. We are going to first look at the notion of relationships between people and between objects. We're going to use that to give the formal definition of relations. We're going to find some examples of relations and what some elements are in those relations. So we have many words to describe different kinds of relationships between, say, pairs of people. Family, friendship, love, and there are some important aspects of these relationships. First of all, each of those relationships can be described as relationships between two people. For instance, for family, two people can be said to be in the same family. Two people can be friends. One person can love another person. Even though there's only one person loving, there are two people involved in that relationship. Some pairs of people satisfy the relation and some do not. So we have lots of ways that we can pair up people. Only some of those pairs are going to make the relationship true. So if you have two random people, maybe they're in the same family, maybe they're not. If you have two random people, they could be friends, they may not be friends. And if you have two people, one may or may not love the other. The next thing is that the order of the people may or may not matter in the relationship. So for instance, if we're talking about family, whether or not person A is in the same family as person B, that means that person B is in the same family as person A as well. So whatever order we put those two people, they either are both in the same family or they're both not in the same family. And friendship is similar. However, love is a little bit different. That does depend on the order. So for instance, say Jojo may love Joanne, but perhaps not the other way around. The order that you state the love relationship can depend on whether or not it's true. So these relationships depend on pairs of people, and the order matters, and that leads us mathematically to think about ordered pairs. In particular, all these relationships can be described by ordered pairs. So as an example for the love relationship, if Jojo does love Joanne, then we make the ordered pair Jojo-Joanne. That is part of the relationship. If Joanne does not love Jojo back, then Joanne-Jojo is not part of the relationship. And so any mathematically precise definition of relations has to be stated in the context of ordered pairs. So I think we're ready for the definition now. If you have two sets A and B, a relation between the set A and the set B is some set R of ordered pairs. Well, what are the ordered pairs going to be? Well, the x coordinates are going to be from the set A, the y coordinates are in the set B. And to say that a little bit more succinctly, R is a subset of the Cartesian product of A and B. So, just a few remarks on this definition. A and B this does not have to be about people. So A and B did not have to be sets of people. Relations can describe relationships between any kinds of objects. And we'll see a few examples of those in a little bit. If the ordered pair A and B, AB is in the relationship, it's an element. Remember that the relation is a set. So if the ordered pair AB is an element of that set, that means that A is related to B in the relation. Another way of saying that AB is in the relation and A is related to B is we can write that as the true statement ARB. So R is part of a statement that says two things are related in the order that they're given. So ARB is the same as saying A is related to B under the relation R. And finally, if the ordered pair AB is not in R, that means A is not related to B in the relation. So ordered pairs that are in the relation, the first one is related to the second one. If they're not, then the first one is not related to the second. So here's some examples with not people. So we'll start with real numbers. I'm going to define the relation R on the set of real numbers, where A, R, B means that A is less than or equal to B. So for instance, we know that 2 is less than or equal to 5. That means the ordered pair 2, 5 is in the relation R. And if we want to put that in statement form, we can say that the statement 2R5 is true. However, 5, 2, that ordered pair, is not in the relation because 5 is not less than or equal to 2, and so the order really matters with this particular relation. All right, so for integers, well, we've seen this relation for integers. We define the relation D, where A, D, B means that A divides evenly into B. So this is really divisibility, the divisibility relation. So 4 divides evenly into 12, and so the ordered pair 4, 12 is an element of D. And again, if we want to say this is a statement, the statement for D12 is a true statement. But 7 does not divide evenly into 19, so the ordered pair 7, 19 is not an element of the relation D. So we can have relations on sets. We've seen some of these before. I'll call the relation S, and S is a subset relation. So A, S, B means that A is a subset of B. Right? So A and B are sets. A, S, B means that A is a subset of B. So we know that Z, the set of integers, is a subset of the real numbers. So Z, R is an element of S. Right? If we want to put that in statement form, Z, S, R is a true statement. But Z is not a subset of the natural numbers, so the ordered pair Zn is not in S. So again, to emphasize, relations can be between any types of objects. And the only real requirement is they have to be relationships between pairs of objects. All right, so now I think you're ready to look at the activities for introduction to relations. That's on the PDF files included with this video.